Good afternoon, all of you. Hello. Is my voice clear? Respond. Is my voice clear or not? Satvika. Sindhuja. Voice clear unda andarki?
Yes, sir.
Okay. Right. So we have completed two transistor analogy. How the SCR is working as a two transistors, that is NPN as well as PNP transistors. Okay. Now we have to derive the equation, that is mathematical analysis, that how a two transistors can be working as a SCR, silicon control rectifier. So let us consider in the off state of a transistor, the collector current is IC. And the relation between IC and IE, we will already known what is that. IC equal to alpha times IE plus what is that, ICVO. What is the meaning of ICVO? It is the reverse saturation current or a common base leakage current of collector to base junction of a transistor. So now for a transistor 1, that is Q1, the emitter current IE is almost equal to the collector current IC. So what is that? IC1 is equal to alpha 1 into IA plus ICBO1. So what is alpha 1? It is the base emitter current ratio gain, collector gain. So common base current gain of a transistor 1. So what is the ICBO? It is the common base leakage current of transistor 1. So similarly, you can see that for a transistor T2, this is not TR1, it is transistor T2, change this. Okay, so what is that? IC2 equal to alpha 2 into IK or ICB2 plus ICBO2. So what is that? You can, what is the IA? IA equal to IC1 plus IC2. If you see here this diagram, IA is equal to IC1 plus IC2. So IC2 plus IC1. So substitute these equations. You will get this overall equation. So what is the anode current? That anode current equal to this. That means by increasing the by transistor current gate alpha is at low emitter current with an increase in the current. So what is that? Well, if your Ig equals to 0, what is that Ig? Gate current is 0. It is simply anode current equal to, it is off. If Ig equal to increases, Ii is increases. Ig is 0, Ii is 0. So there is means there is no gate terminal. If your gate terminal is given to the input signal, it is on. When your gate terminal is off, then what will happen? It is switch is off. It is like a off switch. So like this you can easily analyze by deriving this formula. So something it is not that much important. So just remember, I have already explained how the two transistors can be analyzed through this on and off switch, like on and off switch you will see. Okay, so whenever gate pulse is given, there is first transistor Q2 is on, so that Q1 is also on, so it is on switch. So because
Harsha?
saturation, so if the gate current is 0, then it both are in cutoff, so it is off switch like this. You can remember. So there is no need of this much derivation. Okay. So we will go for a volt ampere characteristics or VI characteristics of a SCR. See, in the VI characteristics of SCR, this is the main important characteristics graph. Very important. So you can also draw in your running notes. Very important. This graph is. So the most of the time they will ask in the long answer type questions. Okay, essay type question they will ask you. So in the how many modes of operation the characteristics can be divided is three modes of operation. First one is forward blocking mode. So what is the forward blocking mode? Means this region you can call as a forward blocking mode. So what is second mode is called forward conduction mode. So this state you can call as a forward conduction mode. So what is the reverse? Third mode is reverse blocking mode. This mode is called a reverse blocking mode. This is called a reverse blocking mode. So this is called a reverse breakdown region or reverse breakdown mode. Okay. So here, what is this? This is the transistor. This is the SCR. So in this SCR, you given a gate terminal G. Capital G is the gate terminal. So gate terminal is given to the some circuit externally. You are given the circuit is producing a some pulses, gate pulses. So it is given to the switch is closed. That means you are applying a gate pulse. So and it is connected to anode is connected to the some load. Okay, and Vs is the input signal source. Input signal source. So load is connected through anode. Okay, so that is the reason it is IA is the anode current, VA is the anode voltage. Okay, and VJ is the gate pulse or gate voltage. Vs is the supply. Okay, supply voltage or source voltage. Source voltage Vs. Now what will happen? So different gate pulses you are applying. So that means depending on the gate pulse, it is turning on time will be depends. Whenever the gate pulse, what is that? Gate current is more. That means gate current is more means it will turns on very quickly. Gate pulse or gate voltage is more or gate current is more, then what will happen? The SCR will be turn on quickly, very fastly it will turn on. Where if you see in the characteristics, Ig1 is greater than Ig2 is greater than Ig3 greater than Ig0. That means if you are increasing the gate voltage, gate current, so gate current is lesser, that means it is turn on time is more. Maybe if you are decreases something less, that means your delay is less, that means it is quickly it is turning on. If you see in the circuit in the characteristics. Okay, so what will happen in the forward current, forward breakover voltage? What is the breakover voltage? This is VBO. So before the forward breakover voltage, some current, very small minute current is flowing in the circuit. That current is, you can call as a leakage current. Okay, so after reaching to this forward breakover voltage, or simply you can also call breakover voltage, it is suddenly changes its direction, and it is after some current. What is current? You can call latching current. Then it is suddenly raising the overall current. It will raises more. So it is forward conduction mode. So what is that? In the breakover, before breakover voltage, it is small current or minute current will flows in the circuit. That is a leakage current. Okay. After reaching this point, what will happen? It is changes its direction, and some current after the reaching to some current. What is the current? Is called a latching current. So after latching current, it will, so the device goes into forward conduction mode. Okay, this is, you can call as a forward biasing mode. This is the total, it is done in the forward biasing mode. So it is reverse biasing mode because the anode to cathode voltage is positive. If the anode to cathode voltage is negative, you can call as a reverse reverse biasing mode. So what is that? Forward biasing mode means anode is positive, cathode is negative. So in the reverse biasing mode, anode is negative, cathode is positive. Okay. So and if you see this, the gate is not applied. Here also the gate is not applied. So in the, what will happen in the forward biasing mode? So what is that? Two junctions are forward biased. What are the two junctions are forward biased? J1 and J3 are forward biased, whereas J2 is reverse biased. That means the either of the total junctions present in the SCR is 3. So in these, two junctions are forward biased and one junction is reverse biased. Then it is overall effect is forward biasing mode. Okay. So and in the reverse biasing mode, what will happen? The J1 and J3 are reverse biased and J2 is forward biased. That means overall effect is reverse bias. The overall effect is reverse bias. Okay. And the forward bias mode, we are flowing a minute current or a small leakage current is flowing. That current you can call as a forward leakage current. Whereas in the reverse bias mode, you are having a current which is also minute current or lesser current that is flowing in the circuit or device, that you can call as a reverse leakage current. Okay. Is it clear? So how many modes of operation? There are the three: forward blocking mode, forward conduction mode, and reverse blocking mode. So in the forward bias mode, we have a two, and the reverse bias we have a one. Okay. So in the forward bias, we have to connect anode to positive, cathode to negative. So in the reverse bias, anode to negative, we have cathode to positive. So VA is called anode voltage, IA is called anode current, VBO or VFBO both are same. That is called a forward breakover voltage. And VBR, what is the VBR? This voltage, knee voltage, this knee voltage or VBR. The VBR is, you can call it as a reverse breakdown voltage. And what is the IG? IG is the what is that? Gate current. Okay. So what is the forward blocking mode? When the anode voltage is made positive with respect to the cathode, with gate circuit is open, already told gate voltage is not applied. So SCR is said to be forward biased. Okay, anode voltage is positive and cathode is negative and gate is open. During this mode, junctions J1 and J3 are forward biased and the junction J2 is reverse biased. In this mode, a small leakage current of order of few milliamperes will flow from anode to cathode. Okay. So the VI characteristics. What is the VI characteristics of this SCR? O2M. So this is O2M. So you can call it as a forward blocking mode. The OMVI characteristics represents the forward blocking mode of SCR. SCR treated as open switch in the forward blocking mode. That means what is that? You can call, theoretically you can call as it is open circuited. That means there is no conduction of current. In the forward blocking mode, the SCR will not turn on. Is it clear? It is in the ideal state. That means it is not conducting any current. The device is not at all, now it is not at all activate, it is not turn on, okay, in the forward blocking mode. So in second case, what is in the forward bias mode is forward conduction mode. Is it clear? In the forward bias mode, we have a two modes of operation: forward blocking mode and a forward conduction mode. In the forward blocking mode, we have a small leakage current which is flowing in the circuit or a device. So it is not at all turning on the, not at all it will turn on the SCR. Okay. So in the forward conduction mode. So what is the forward conduction mode? We already seen that region N2K. N2K is called a forward conduction mode, or it is called a on state. You can also call on state. So in the forward conduction mode, what will happen? The thyristor can brought from forward blocking mode to forward conduction mode. Okay, and the positive gate pulse is between gate and cathode. Is it clear? So here in the forward blocking mode, you are not applying any gate pulse. It is open circuited. So whereas in the case of forward conduction mode, you have to apply a small gate pulse. This is the first criteria. And the second criteria also you have to on the SCR by also increasing the forward breakover voltage. Is it clear?